11. Trying to see if we can stream on LinkedIn, but appears to be a bit of a glitch here. But we'll just start. Okay, good morning, everyone. I trust we are all doing great. We will get right to it because we have very minimal time to deliver on this. My name is Anthony Ayuno, and I'll be your host for this session. Today, we are discussing auditing APIs. In today's digital world, APIs have become ubiquitous in enabling business interactions and communications between systems. There's an EC Council quote, that highlights the vital role APIs play when it said in one of its articles that if software is eating the world, APIs are the teeth. Gartner predicts that this year, API abuses will become the most frequent attack vector. Why? Hackers consider APIs to be low-hanging fruits, right? Some of the major API breaches we had last year involved even our darling LinkedIn, over 700 million user data exposed. If we are familiar with Clubhouse, about 1.3 million user records exposed. There's this social media app in the US called Parler. They were able to steal about 60 terabytes of data, right? Unfortunately, securing APIs remains a significant challenge for institutions, primarily due to weak API governance practices. I was in an interview panel yesterday where one of the participants talked about how an organization he was auditing couldn't even produce an inventory of the APIs in production. Like, seriously, how do you secure what you don't even know exists? These are like foundational stuff, right? But again, you'll be shocked to discover that these risks may even exist in your own organization. Other challenges with securing APIs include poor coding practices, the inexperience of tech risk or cyber risk practitioners in providing that reasonable assurance on the adequacy of API risk management practices, right? And that's why we're here today. So at the end of today's session, you should be able to provide that reasonable assurance and advisory on API security as a tech risk practitioner. As a developer, you will understand why certain risk management practices are not a waste of your time. There's that tendency for our IT folks to just feel that some of the things we talk about are just meant to bog them down, right? So you understand that certain risk management practices are not a waste of your time, but a necessity if we are to build solutions that stand the test of time. One of my mentors, a CISO, recently said in a forum that, you see, as tech and cyber risk practitioners, your appraisal is not just done by your employer, that's your HR or your supervisor, but these days they are done by hackers, right? I've seen instances where a head of IT audit was fired because of a breach, a CISO fired, CIO fired. Why? Because of a breach. So we must stay woke by continuously building capacity. Our faculties this morning are one of the best brains, I'll say. Chinedu Onwukike is a security engineer with Amazon Canada. He has struggled to be here with us. When you check their timing, this is about, say, 6 a.m. there. He's an offensive security certified practitioner. He's a certified ethical hacker. He's a certified information systems auditor, among several other certifications he possesses. Ibrahim Mustafa, and that speaker is under Beautiful Mind. He has recently joined one of the foremost banks as a lead in the IT audit department here in Nigeria. He's a software engineer, right? He's a software engineer and a certified information systems auditor. Then there's Ife Ogubambi, who leads the cybersecurity operations team in one of the tier 1 banks here in Nigeria. So I'll say You sit back, relax, and take away distractions. You can post your questions in the chat, and we'll, as much as possible, try to attend to them. We won't be able to take questions during the session because of the limited time. So, Shayi, if you go to our outline, we'll have conversations around what an API is in, say, 20 minutes, and then we'll discuss common API flaws in under 20 minutes, and then we'll now share and talk through an audit program in under 20 minutes, and then we'll take questions and wrap up. Now, we are not unmindful of the diversity of our audience. So we have some of the technical folks here, we have non-technical folks. I'll plead with our technical folks to be patient as we try to ensure that the non-technical folks are carried along. I also plead with non-technical folks not to be put off by some of the technical jargons you'll be hearing, JSON, blah, 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 and all that. This is like a 4-day course that is being compressed into 60 minutes, right? So while these recordings will be made available, you can appreciate the struggle. This session is meant to whet our appetites towards building competencies in this knowledge area, right? So we'll start off with Ibrahim. Ibrahim, over to you.
All right. Thank you, Tony. Can you elevate Ibrahim, please? Elevating scores.
I think he can share even if he's not co-host. Oh, okay, he is. He's a co-host now.
All right, thank you very much. Good morning, everyone. Can you confirm if you can hear me? Am I audible?
Yes, we can hear you loud.
All right, thank you very much. Good morning once again. You're all welcome to this wonderful knowledge sharing session, which is going to be taken in 4 parts. And once again, my name is Ibrahim Temita Mustafa, and I'll be taking the first part, which is talking about what an API is. Now, straight into the business of the day. What is an API? The bigger question, and we've been able to come to an excellent and concise definition of what an API is. Please go to the next slide. What an API is, and we've been able to identify that an API, application programming interface, is a set of programming code that enables data transmission between one software product and another. It contains the term of the data exchange. So that is simply what an API is all about. And we have on this screen a diagram that is trying to depict what an API is. On the left-hand side, you will see that we have an application on the left-hand side trying to communicate with another application on the right-hand side. And we have in between an API service that is bringing these 2 applications together. Consciously or probably unconsciously, we have been experiencing these API services in our day-to-day activities, which I would like to give an instance of. Take, for instance, we are trying to send some funds to a beneficiary in another bank. You will note that when you launch your mobile application to send funds to another person in another bank, you supply the individual's or the beneficiary's account number, and you see that it brings out the names and some other details that are related to the beneficiary, which means that this information you are looking at that moment is not available with your own bank or organization, but it resides with another organization that you are trying to relate a transaction with. So this is an enabler by API, which means the other party or the other organization has exposed an API service that would allow any third party to be able to consume their services and provide information to whoever that is making a request. So we have here on the first image, which is a web API browser, and it is a communication request from the client application software, which is what I explained earlier, that an application is trying to reach an application B. So it can either be from a web client, your browser, or your mobile application. The basis is that a request is made, and you will see that a request is made to try and connect to the API via an internet connection, which means that the API is somewhere hosted in the cloud or within an organization. We'll get to that a bit to see the types of API that we have. So you can reach this API via this internet medium, and these process the request from the web client or the client to the web server of the application B that you are trying to reach, where the business logic, the security metrics, and all other parameters that would enable seamless communication and secure communication between application A and application B. And if you look at those the communication pointers, you will see that communication is coming from API to web server, and this pointer is showing that this web server is having access to the internal database of application B that is hosted somewhere else. So which means communication has reached the web server and it has gotten to the database where those vital information are stored. Then a response is now being activated or initiated back by the application B. You can see it's respond back to the web server only, and the web server respond back to the API. The API respond back via an internet connection and back to the web clients, which is some of those things that we experience in our day-to-day activities. Can we move to the next slide? Okay, so the type of application program interface, we have a public API or private APIs. Most of the time we call these public APIs open APIs, and I'm very sure you must have experienced these public APIs whereby a lot of companies or blue chip or these popular organizations have their API services exposed for developers to consume. Taking for instance, probably you've been trying to log on to or sign up at maybe a LinkedIn or a relevant application, and you come up with this pop-up that says, do you want to log in with your account, maybe your social media account, your Twitter, your Facebook, or LinkedIn, which means LinkedIn, the application is going to leverage on API services that are being exposed by Twitter, Facebook, or LinkedIn, which means you don't have to go the round of developing authentication in your own application. You can leverage on the services exposed by these beautiful platforms to leverage on. Another good example is we have Google Places API, Twitter APIs, Google Analytics, and I would like to take an instance of where we have Uber, Spotify, and both transport organizations where they leverage on Google APIs. You know, it is a ton of technological investment to start developing Google or a map technology that will assist you in navigating around, make some serious calculations on how you have fared. But we have Google APIs that these organizations leverage on their open API services. And one of the advantages of open API is that it enables innovation, connectivity, and enables this company to have more visibility to, in fact, create integration with a lot of institutions that they would not get a direct integration with. And when we look at private APIs, this is talking excessively with maybe we have an organization that we are trying to relate different applications together. These applications are supposed to be dependent on each other, which means we don't publish these public APIs on the internet. So unlike the public APIs, the APIs are hosted on the internet where developers can actually consume the documentation are out there in the public, and they can make use of it to enhance their business objective. But unlike private APIs, these are organization-based, which means these APIs are hosted within the organization, and necessary privilege and access are developed in order to ensure that these APIs are consumed. For instance, we have our Active Directory in an organization, and we have a host of 15 applications that are ready to be utilized, which means we don't have to bother ourselves on developing authentication on each of these applications. For instance, we have an HR portal and a credit portal that is trying to connect to each other. So I want to take a credit from my organization and logging on to the HR portal on the credit portal by supplying my staff ID. It brings out other details, which means it depends on other applications that already have the details that will enhance the process. So that's about public and private APIs. I'm sure we are still going to go online to read a lot about that. Now, API lifecycle, overview of an application program interface. So we have like 6 phases of application lifecycle, which I'm going to dwell on, and I'm going to talk about the importance and the associated risk in each of these phases. we have the first phase to read is design, call it plan or designing, which means for every API, there is a need for them, which means a business unit or a business entity has decided to bring about a business that will enhance profitability of the organization, and they need to develop something that will be like an enabler. So an API want to expose some data to some third party to enable us to have a business a relationship with them. Then we'll talk about how to design this and have a specific requirement on what we want, because API is more like we are trying to expose our data, our information to a third party. So it has to come with a very good and quality design and planning. And to enhance scalability, if business model has changed, we have to be able to incorporate that, which means design is one of those areas that we need to look at effectively and understand that it is well documented. And development is the next stage, where the APIs are developed by our software engineers. And as a security professionals, we try as much as possible to ensure and validate that these APIs are developed relative and accurately to what the business has required. So as a security professional, it is important that we look at this area and ensure that what an API requirement is what it has been developed for. Then we move on to testing. As we all know, testing is one of those important areas to dwell on, whereby we have to ensure that all modules, functions, methods, and all other programming technologies and logics that we have used to come about this API are tested for our security controls and adequacies. We have to ensure that these security controls are available and they are adequate and they were effective. Now, I'm sure subsequent slide and other part of this session will take care of a lot of security concerns. The implementation. Now, this is where we have our API published. So, which means the API can be published either on the public server, internet, or we have in a private organization server, whereby it is ready for consumption. And at this stage, there are a series of documentations, series of access control and privilege management that must have gone into places before we can conclude the implementation phase. So as a security professional as well, we need to be able to identify that these APIs were implemented to ensure that they were documented and they were published appropriately. So which means access control and all other security are factoring at the implementation stage. Then this brings us to the next level or the next phase of the application program interface lifecycle, which is the reusage, which means APIs are ready for consumption. Now, this is the point where we look at, do we have APIs that have been developed and they are currently in use, currently active, they were effectively utilized by third parties or internal applications, or we have APIs that have been developed, but they are not being used. Most time we call them orphan APIs, which means in an organization, there are some cases where you have APIs that are developed and they were never utilized, probably because events has overtook the need for the APIs. However, it is important that security professionals that we identify all the developed and published APIs so that we can identify which API is not used, so that we can mitigate against unnecessary exposure or leveraging or utilization of orphan APIs by malicious users. Then we have maintenance and monitoring, which is to ensure business specification and the API service CIA principle, which is confidentiality, integrity, and availability are not compromised. So which can be achieved through monitoring and maintenance, which means we have to ensure that a maintenance mechanism and monitoring are developed, which can include logging and having some solution like our SIM solution to have an oversight to be able to proactively mitigate against vulnerabilities, which I'm very sure subsequent slides in this part of the session will take care of. And finally, we have optimization, which is a continuous improvement through versioning and change management, which means, of course, there will definitely be need for us to enhance what we are exposing, how we are exposing our data, and what the business requirements probably has changed, and we want to ensure that the API services is still meeting our business objectives. So optimization is where we come about versioning we ensure that our API service is effective and available to our third party to ensure business continuity. So that's that about API lifecycle. And this brings us to how API works, which means like what we have on the slide, that without doubt, communication enablers are the APIs services, which means that they are the real deal in ensuring that application A is able to communicate with application B. So they are communication enablers. And we have three terms there: standards, protocols, and architecture, that we use interchangeably to define how communications are done on API service, which is greatly on SOAP and REST. So SOAP is a technology which is simple object access protocol by definition, that was originally developed by Microsoft, that relies on extensible markup language, which means that this protocol uses XML data format for their messaging services, which means application A and application B will be able to communicate based on extensible markup language data format. And there are a lot of limitations to SOAP, and technology-wise, there have been a serious development which brings about what we call REST, RESTful APIs, which is representational state transfer. It's a similar protocol to SOAP, but it's leveraged on the weakness and the shortcomings of SOAP. And as technology has demanded, we have to find a way to enhance how we communicate between application. And subsequently, the next slide will shows instances of what we have here. Can you go to the next slide, please? So the next slide is showing instances, samples of SOAP request and response. Then we have REST request and response as well. On SOAP request, you will see that we have a basic HTML data type that is being sent as a request for an application, an IBM request, trying to make a connection with another application, and sending an XML format. The lower part on the left-hand side is the response provided. You will see these are XML format as well, whereby you have to decode the XML to get you can see the version, you can see the XML format, and you can see the content of the response. A price was returned 34.5. So software developers and engineers will understand that it takes a lot of technology effort to translate what these XML format is. But on the right hand side, we have a REST request and REST response, which is more advanced and can practically communicate on different data types, a lot of data types like JSON, YML, RSS, etc. So we have an instance here where we have an API request sent across on a Facebook API to request for a Coca-Cola information, and you can see the response that was given, which is very even readable from the look of it. Another instance downstairs that you can see request and response, you can see how simple it is. So of course it can be explained extensively in this little space of time, but I advise that we go online to read more on SOAP and REST. Then this is a brief difference between REST and SOAP. We have identified documentation, data format, performance, cacheability, security, reliability, and other usefulness as the major differences between REST and SOAP. The fact that SOAP is one of the earlier web services which now metamorphosized into API is the fact that they are still in use in some applications. However, REST is a predominantly used API services. And you can see, I would just like to mention one or two, and we can read up on that. Security is one of the major aspects that differentiates REST from SOAP, which is REST support SSL. Of course, SOAP to support secure socket layer connection, but it takes a lot of other additional features before we can achieve that, and it can be more complicated. But on REST, it's very seamless. And data format, as you can see, REST permits many different data formats, while SOAP permits only XML, which means if I have an application probably on a Microsoft operating system based, and it can only understand XML language, that means I'm limited to what other application that I can speak to. Well, on REST, the limit in fact, there's no limit. So you can actually leverage on REST APIs to achieve communication with third-party application. The next slide, please. The next slide, please. Okay, so now in the earlier image that we try to depict, we have an application on the left-hand side and an application on the right-hand side, which means that two applications are trying to communicate and API is sitting in between. So what we have here is an instance of the REST API technology URL that enables this communication. What we have is what is used by application A to get to application B. Now, we have a protocol. All these API services are based on HTTP protocol, and which means that it's the standard by which different applications communicate. They leverage on HTTP to communicate. And like I said, it is hosted, these API are hosted either on the local network or on the internet, which we can resolve. Then we have the port, which can show us how we can access these API. And the last part is the RESTful endpoint, which is the detail of what we have hosted, the API services that we have hosted on this location, which means the instance we have is a HR service. So HR service can be as many as possible, can be probably you want to perform different actions, but for the purpose of this knowledge sharing session, we have HR service and we have the version, like I mentioned, the lifecycle, we have versions and all other areas that we maintain. So version 1 here, and one of the resources that we're trying to reach is the users in the HR services. There can be other services or other resources that we wanted. So an application is trying to reach the HR services to get a user, and it is trying to supply the parameter, which is an ID of the user, which the third-party application will return. So that's that about this. It's a API client web application. Now, we have what we call API actions. What actions can be performed on APIs? Now, API applications, we have a get, post, put, and delete actions, which is very, very important, which means for get action, we are trying to give a read-only access to our information, which is we are only able to retrieve data from a third-party application or from a third-party software, which means database, which means that a get is one of those critical functions that is dependent to get information. It may not be too critical because of the action, but however, if we look at confidentiality and data disclosure, it is important that we emphasize on the security to identify who is having access. As you can see, we have a get. This is an instance of trying to find a pet by its ID on a third-party application. Let's say this information of this pet ID, let's say it is vital to perform a malicious activity on that third-party application. Then it is important that we identify and authorize who is going to have access to this get action. Then we have a put action, which is to update an existing data. Now, look at the put action in this image below. You will see that you can update an information on another application database. For instance, I have 1 million naira in my account, and because my institution has exposed an API to, and the API is not securely developed, somebody was able to leverage on this put action and modify my account balance to 1 million, 200,000 naira from 1 million. You know, it's a serious compromise, and you know, it's only a matter of time to have a reputational damage to such organization. Then we can also have delete action, which means you can from one application to perform another delete action on another organization's data, which without that, you understand that this is one of the critical actions that needs to be monitored, which emphasize on why we need to understand who and who have access and what privilege do they have to access the API. Then we have the post, which is one of the most vulnerable. As you can see, post is used in uploading documents, images, file types of different kind that is accepted, which means it is possible for a malicious user to upload malicious content, scripting and others malicious script to bring down a whole organization system or to cause a service availability issue and amongst other issues that can arise. So I'm very sure that other parts of this presentation